There are a number of ways that moisture moves around in homes, and the reason why moisture is so important to us is moisture and the way that a home deals with moisture is going to be very much related to the durability of the home, how long the home will last, what kind of damage it will sustain from moisture. All homes are generally taken out of service because of mainly two things, either moisture or fire. And so let's talk about moisture so we understand how to protect homes from moisture, that we understand how moisture moves in buildings. The first way it moves is by gravity. I mean, rain simply falls on the roof, and the rain falls off of the roof. Water builds up here around the foundation. This is very common, happens in many, many buildings. And we also might have the problem of plants growing near the home and the plants being watered. So we have this zone here that can become very wet. And when this area becomes wet because of rainfall, because of water falling off of the roof, because of sprinklers, the water can saturate the foundation, and the water can actually move up through the foundation by something called capillary action. Right here we have an area where the water can actually be transferred from the masonry, which can handle it pretty well, into wood. And it's not that water hurts wood, it's that water provides the water that pests need. This water coming from the ground can wet the wood to the extent that it becomes a good food and housing for pests like termites, carpenter ants, and various types of fungal infections of wood. So what we want to do is we want to keep the foundation dry. If we've got a lot of rainfall, if you live in an area where you have more than 20 inches of rain, if you have rain coming off of the roof and wetting this area right here, we suggest you might want to install a gutter and some downspouts to lead this water away from the foundation. If you have shrubs and bushes around your home that need watering, maybe you should remove them. There's a lot of houses that have termite damage, carpenter ant damage, and it's because of this watering problem and because of water coming off the roof. So it's very important to understand how this is happening and to prevent it from happening. Now, in a new home, what we want to do is install some type of plastic barrier here, plastic metal barrier here that offers some kind of what's called a capillary break. And that a capillary break prevents the capillary action of water coming up here and going right through the concrete and into the wood. Now let's look at a combination of capillarity and diffusion. Whenever we see this word diffusion here, we're not talking about liquid water anymore. We're talking about water vapor. So capillarity is water and diffusion is water vapor. Now here we have a concrete slab. We have a big blow up of a concrete slab here. And down here we have wet soil or gravel. And we have the water table all the way up to the bottom of this concrete slab. Now there's two ways that the water can get through the slab. One is by capillary action. In other words, some water molecules that are bonded together in kind of a droplet or a continuous stream can actually claw their way and climb up the very small interstitial spaces of the concrete and come out on the other end. And they can either come out as a droplet and evaporate in this case. Or there's another way that water vapor can move through materials that are air barriers but are not vapor barriers. The reason why a material could be an air barrier and not a vapor barrier is that water vapor molecule is much smaller than an air molecule. So a water vapor molecule could actually enter here and work its way up as a vapor, just kind of bouncing around in here, in between the spaces, and finally come up and emerge here as water vapor. So that is called diffusion. That's called vapor diffusion. When it's wet down here and it's dry up here, the water can diffuse through the concrete slab as a vapor, or it can travel as liquid water by capillary action. And both of these methods of moisture travel can bring a lot of moisture into the house. What we're trying to do with moisture is trying to find the source of the moisture so that we can stop it. Trying to ventilate it out or trying to use dehumidifiers is a secondary type of solution. The primary solution is to try to stop the water from getting into the house before it gets in. Now let's look at a combination of air leakage and diffusion through a wall. So we have a wall cavity and we have dry wall on one side of the wall cavity. This is the inside. And then we have some type of sheathing like OSB on the other side. OSB, plywood, or 1x6s or 1x8s in older homes. So there's two ways that water gets through a wall cavity. One is through air leakage, and this can transport a lot of water vapor. We've got very humid air in here, dry air out here. The vapor-laden air wants to go through the wall cavity. The vapor-laden air is driven by actually an air pressure difference. If the air is denser in here than it is out here for some reason, then that's going to drive the air through the wall cavity. An example would be is if the house happens to be pressurized because there's a huge return leak, say in the crawl space or something like that. So a lot of outdoor air is being pushed through the furnace and into the house. That would pressurize the house. So that would have a tendency to drive air through the wall cavity. And if that air happened to be moist, then a tremendous amount of moisture could be carried into the wall cavity by this air leakage. The other way that moisture can be carried into the wall cavity is by vapor diffusion. And this is a much slower process. But again, the water vapor, because the molecules are smaller, can go right through the drywall. It's a slow process, but it can carry a considerable amount of moisture into the wall cavity under a couple of different conditions. Let's just say we're in Helena, Montana, and the temperature outside is varying between, say, 15 below zero and 0. Well, that air, that outdoor air, is extremely dry. Whereas the indoor air may be 50 or 60 or 70% relative humidity. So that creates what we call a large vapor pressure. Anytime there's a lot of something on one side of an enclosure and not very much on the other, that creates a pressure for the whatever it is to move in that direction. So in this case, we're talking about water vapor. If there's a lot of water vapor on this side of the wall and hardly any water vapor on this side of the wall, then the water vapor is going to travel through the materials until it reaches equilibrium. And well, what's wrong with that? We've got water vapor. Why is water vapor a problem? Well, the water vapor isn't so much of a problem, but what happens is we get condensation, because we have this cold surface, and the water vapor moves through here until it reaches a dew point. And the dew point might actually be right here. So we have water being formed right on this line. Everything beyond this line is wet. So that's called a dew point. And the reason why that condensation occurs is that air, which is also in the cavity, as it cools down, and the water vapor itself cools down, the water vapor will condense at a certain point called the dew point. And the dew point is actually a temperature. So you may have 70 degrees right here, and let's say that we're in a very cold climate or something, and we have 10 degrees out here. So this is 70 degrees, this is 10 degrees, so somewhere in here we may have something like 40 degrees. And 40 degrees may be the dew point. And so if it was the dew point, then that would be the point at which the insulation would start to get wet. But there's a lot of moisture deposited in wall cavities because of air leakage and because of vapor diffusion. First of all, on the wall is we need an air barrier. We want to stop the air from getting into the wall cavity, because the air is what can take the most water vapor into the cavity. That's what we're really worried about. But in some climates, in the very cold climates, we might also want a vapor barrier to keep the vapor diffusion from happening. And so that's the way that moisture flows through walls. Now the second way that we might get a flow of moisture through a wall like this where it could be a problem is in a warm climate. Now turn this around in your mind and let's pretend that this is the outdoors and this is the indoors, because we have a cold air-conditioned area in here and a warm humid area out here. Okay, we got a hot humid area here and we have a cool dry area here. One of the things that air conditioning does is it removes moisture from the air. So we have a drier air inside the house than we have outside the house. This is part of delivering comfort, is taking the humidity out of the air. So now we have a hot, humid air, which is just loaded with water vapor. We have a ton of water vapor here, and not much water vapor here. So again, we've got a vapor pressure. And if we had some type of a negative pressure inside, let's say that we had exhaust fans running, or we had the dryer running, or the water heater, which has a chimney which exhausts air out of it, all those things could depressurize the home, which is now over here. And it could cause a movement of air. That warm, moist air could actually get into the wall cavity from outdoors. And so, in moving through here, again, it could find its dew point. Let's say that the temperature is, 95 degrees out here, and it's 75 degrees here. So somewhere in between, we may get to a dew point of, say it's 80 degrees right here. Well, 80 degrees may be the dew point of that air, meaning that if you have a really hot, humid day, and all of a sudden you cooled that temperature of the air off, let's say some cold front came in, well, it would probably start raining, in that case. So that's what happens. Actually, inside this wall cavity, there's kind of weather going on in here. There's, some warm air that's coming through here, and it's meeting a cold front right here. And there's some rain happening inside the wall. Vapor could also diffuse through the wall. So the vapor from the outdoors could diffuse through the wall, add to the amount of water vapor in here, which could create a lot of condensation. The condensation could occur right on the back of the drywall here. It could wet the drywall. When the drywall gets wetted, it can grow mold. It loses some of its structural strength. It's not something that we want to happen. So the two things that we're worried about happen mostly in the more severe climates, the hot, humid climates and the cold, dry climates. And again, water vapor is not our enemy. What is our enemy is liquid water, because liquid water wets building materials. And when it wets drywall, the drywall is softened and it loses a lot of its structural strength. When masonry materials are wet, the wetness sometimes carries some of the Portland cement and chemicals out of the material. And water can also cause rusting in steel, and it causes rot in wood. So it can do all kinds of mischief. Water can do all kinds of mischief. Water vapor isn't such a problem, but when it condenses, it hurts buildings, and that's what we want to be concerned about, and that's why we want to know about how moisture flows through a building.